Okay, so good evening, everyone. So welcome to this live session for control engineering. In this session, we'll just discuss some basic problems. So more specifically from week one content. So some very basic type of question we'll discuss. So I'm Parthasarthi Mahapatra. So I am a research scholar at IIT Madras. So I will be conducting this live session. And to make this more interactive, so I will present this question like some kind of multiple choice. So you can try first and then answer through poll. So you can find your poll like in the Google Meet. There will be some like triangle, rectangular, some kind of image there, right? So in the you know below of that your right corner, so you can answer the question from there. And then after answering that question, I will discuss the question in detail. So if you have any doubt regarding any question, or any question is not clear, or you have any doubt, you are free to like interrupt me. Okay, so I hope I'm audible, and also the screen is also visible. So okay, so let's start with some basic problem. Okay, so you may have seen this type of question in like this week one NPTEL videos, right? So I hope you have gone through all this lecture video, so it will be easier for you then. So these are all basic questions. So we have a prey predator model. So you know what is prey and predator model, right? So you have some kind of prey which like deer or something that feeds on natural habitation, and predator which actually feed on the prey. So this is some kind of model with many assumptions like. So like this prey have only unlimited food supply, and predator actually feeds only on the prey, and so on. So you have these dynamics that actually describe that. And the prey and predator model dynamics, that is the X is the prey and Y is the predator. And you have to answer this question like what happens when this prey actually goes to zero. Okay, so I'll start this poll, you can answer there. Okay, so this question one. Okay, so I hope you can see the poll, and then you can answer. Okay, so this is just direct question, so you can take like 1 or 2 minutes and answer. Okay, so yeah, if any question is not clear, we can ask. Okay, so yeah, I hope you can see the poll, right? Okay, so okay, then we'll discuss this question because it's just direct question. So if in the absence of the prey, okay, so that means you have X equal to 0. So then the predator model dynamics will be just gamma times Y, because X is 0, right? And the solution of this ordinary differential equation you already know, like this is just the exponential of something this type Y with some initial condition, any initial condition that is given at the time 0, that is y0 equal to y at the time 0, then this is the solution. And if you can just check it also, like this is the solution, then you see that this exponential, because it is e to the power minus of something, this graph will be something like a decaying, and it will go to 0 as time goes to infinity. So the answer will be like predator population will decay exponentially. So this is the answer. Okay, so then we can just move to the next question then. Okay, so again we have a prey predator model, but it's somewhat modified. That is, we relax some assumption there. So in this model, so then you have to find the equilibrium points. So the equilibrium point means that if your system is there, that is your prey and predator numbers are such that then the system will remain there without any external disturbance or any external input or something, right? So then you have to find this equilibrium for this. So again I'll create this poll, you just answer this. Okay, so for this question you have multiple options, so you can choose more than one also. Okay, so you can answer through the poll. Okay, if you have any doubt regarding question also, you can ask. Okay. Okay, so then I think we can discuss also very basic type of question. So the equilibrium point means that okay, explain more about prey predator model. Okay, okay, I thought that you already have gone through this lecture video, because there it has been explained very well. So I'm just I will explain it very intuitively or very superficially. If you still have doubt, you can just revisit the lecture videos. Okay, so for example, the prey predator models means like for example, let's consider one kind of jungle or something. Okay, there are some deers are there, so they feed on like natural habitation like grass or some tree leaves like that. So these are called prey, and the predator will be like that actually feed on the prey. Okay, so for example, there could be some leopard or something that actually feed on this deer. Okay, so this prey predator model will be dynamics will be such that then you know that your prey will eat on this grass like for this deer, and that deer will again be food for some predator. Okay, so its rate of change will be dependent on like how they multiply. Like this prey will be dependent on how many already deers are there, and it will also decay similarly in the presence of predator or this like leopard or tiger or something, right? So that for that you can see this depend on for example this previous model, uh, you see that there is some kind of dependence on this rate of how many preys are there. There are multiple changes or changes in the prey, or how they multiple dependent on the number of prey already presented, and it will also be decayed by the presence of predator, because the predator will eat them. Okay, so similarly predator will depend on the food, that is the presence of the number of the prey, and the predator will also multiply with respect to how many predators are present there. Okay, so this is how this model works. Okay, so we have some kind of assumption there, like this prey will have like unlimited supply of food, so that in the absence of like they don't have any issue with the food, and the predator will only feed on this one type of prey. Okay, for this simple basic model. And for the this modified model, you have like some kind of assumption is relaxed, that is you can see that this term is extra present square as compared to the previous one. So that means that even though there is no predator, that is this y is 0, y is the predator and x is the prey, so in the absence of the predator also this number will also decrease, right? It will decrease and become a constant, that is the prey will not grow indefinitely, or go to infinity or something. Similarly, for the predator, we relaxed one assumption here, that is they not only feed on the prey but also they have other types of food supply, that is not only one type of prey is present there. So for that also we have this extra nonlinear term. Okay, so I'm just basic things I'm just explaining. For detail you can just go through the lecture video. Okay, there is, it already been explained there. Okay, so for this problem, so to find the equilibrium point, that means the equilibrium point means that your, okay, the equilibrium point means that whenever this prey and predator numbers are such that they are present in some value, then they will remain at that value. That means there will be no change in these numbers. Okay, that means dx by dt, that is the change in the prey numbers and the predator number, will be 0. Okay, for this equilibrium point. So you just equal them equal to 0, these two equations, then you solve for what value this actually condition satisfy. So that will give you the equilibrium points. Okay, so that means you have this equation, first equation, from first equation you have this equal to 0 and y equal minus, from the second equation you have this equal to 0. Okay, so then you have to find under what condition these x and y, these are 0. Okay, so this means you can take common x there, so you have 5 minus 2x minus 4y, and 1 is this y, 1 minus 3y plus x. Okay, this both are equal to 0. Then you can see that one solution will be x equal to 0, y equal to 0. Okay, so that means there is no prey or predator, then the system will remain there indefinitely. So this is one trivial equilibrium point. Other equilibrium point will be solution of these two equations, that is 5 minus 2x minus 4y equal to 0, and we have 1 minus 3y plus x equal to 0. Then you just have to solve this system of equation. So you multiply 2 in the second equation, then it is just 2 minus 6y plus 2x equal to 0. Then you add this these two equations, then x will cancel out. So we have 10y equal to, then we have 7. So imply that y equal to 7 by 10, and we can also compute this x from this equation, that is x equal to 3y minus 1, or equal to, we have 21 by 10 minus 1 equal to 11 by 10. Okay, just basic computation of this, you have to solve this equation. So then you see that the equilibrium points are 0, 0, that is the trivial one, and another one is 11 by 10 and 7 by 10. Okay, so these are the two equilibrium. Okay, yeah. Okay, so I hope it is clear. Okay, okay, so then if no doubt is there, then we can move to next question. Okay, okay, so then so you have already learned about this system, like classification, some basic classification of systems like linear, non-linear, static, dynamics, or causal, non-causal. So you have to choose, like, from this option which systems are causal. Okay, so you can just intuitively analyze how this system depends on this input, the output of the system depend on the input, then you can just find out this system whether they are causal or not. Okay, so again I'm creating one poll, so you can just answer. Again you can choose multiple option here. Okay, okay, so also this is a very basic question, if you know the definition of causal and non-causal system. So you can answer through poll. Okay, Okay, yeah, you can answer the poll. Okay, you can see one poll option there, right, in your the right or bottom, some triangle, rectangular, circular symbol is there. So click there, then you can see poll, right. So instead of chat, you can answer there. It will be good. Okay, so and as I said, we can have multiple option also here. Okay, so more than one option is true also. It's possible that. Okay, so then, okay, yeah, I think you can see the poll. Okay, okay, yeah, yeah, yeah. I'm not launched that, and now I've launched it. You can see now. Yeah. I hope you can see the poll right now. Yeah. Okay.
Hello, sir.
Yeah.
In question number three, I just clicked on option number A and B,
Uh,
but A get as selected
okay.
is not seen over here.
Okay. So maybe multiple option is not okay. I have to check. Okay. Anyway, no problem. Okay. Yeah. It's fine if you can just choose one option also. Okay. I think I have to see the setting to set it in multiple option. Okay. Yeah.
Mhm.
Hmm. Okay, so anyway, we'll just discuss this question. Yeah. So it's just for for self practicing or nothing else. Just Paul. So as you know, this causal system. So what is the difference between causal and non-causal system? So the causal system will be it depends on the output will be dependent on the input that is has been happened through the past up to present time only. Okay, so there is causal and effect of this. One will be like the input that has occurred through the past up to till now, that will actually affect the evolution of your output of the current time. For this current time, it will depend only on the past and present only. Okay, so for non-causal system, if your output is some kind of function of a future, what will happen in the future, that is the non-causal system. So from this option, you can see that one like thermostat based AC, so it will just regulate your temperature. So it will just depend on your current temperature, right? So it's just a causal system. Similarly, your motor and generator, so they will behave like however whatever input you give, it will depend on, maybe it will depend on the past input also, but up to only present input it will depend the output at a present time. It will depend only up to present time, right? For past and up to present, it will not depend on the future time, like whatever input you are going to supply in the future, its output will not going to change according to that. So as you can see, both A and B are like causal system. Okay, so what about this missile guidance system? So in general, in real life, all the system will be causal, but in the missile guided system, what you do, so you are guiding your missile to some kind of target. So the target could be moving or something. Okay, so then you have to predict like how this target will move, and you have to move your missile in that direction, right? So in some sense, you have to estimate how this your target is moving. So what will be its position in the future, and in accordance to it, you have to move your missile. So in some sense, your system will be dependent on the future position of your target. So you can see this system will not be causal system. Okay. Okay. So okay, then we can move to like next question then. Okay. So you have a system that is actually governed by a simple equation, that is the output input relation, where y is the output and x is your input, and then you have to find whether this system actually what type of system. So you have this all classification, and in what category this system falls. Okay, so Okay, so I'll start one poll for this question. Okay, so you can see your poll for this question number 4, so you can just answer. Okay, so you know how to check this, right? Linearity property. So you have to check like two conditions, that is superposition and homogeneity. And for causal system, you can just see whether it depends on future input or not. Okay, so okay, so then I'm ending this poll and then we'll discuss this question. Okay. So we have this input output relation that is given by this equation. So first we check whether the system is linear or non-linear. So as I said, you have to check two properties. One is superposition. So superposition means that if you have like output for some control inputs, then you take the superposition, that is the summation of all this input, and see whether the output also follows the same property, that is the output is the sum of all the individual output. So then you know that the superposition property is satisfied. And the second one is like homogeneity. So homogeneity means that if you multiply your input by some scalar quantity, that is you scaled your input, then the output will be the scaled version of the input. Then if this condition is satisfied, then you call that the system is homogeneous system. Okay, so this homogeneity property is satisfied. So let's just check it. So for superposition, we can just verify with two inputs. So if it is satisfied with two inputs, two types of input, that is the x1 and x2, then it will also satisfy for any arbitrary number of other input also. Like that is, if it is satisfying this superposition property with x1 plus x2, then it will also satisfy for x1 plus x2 plus x3 and so on, right? So for 2 it's just enough. So let two input is there, x1 and x2, and let the output, corresponding output be y1 and y2. Okay, and because you already have this relation y equal to e to the power t xt, so you can see that for this x1, this y1 is simply e to the power t x1 t. Okay, and for this y2 it will be e to the power t x2 t. Okay, so then we have to check whether for your input x1 plus t plus x2 plus t, the output is y1 plus t plus y2 plus t. Okay, so let denote this by xt. Okay, we just denote this by xt. Then you see that the output will be yt will be equal to e to the power t xt, and xt equal to x1 plus x2, so you have e to the power t x1 t plus x2 t. Okay, and you can just write them as x1 t plus e to the power t x2 t, and you can see that this first term is y1 t and the second term is y2 t. So you see that you observe that if the input is like x1 plus x2, then the output is, you are getting that's the summation of the individual output for x1 and x2. So the superposition property is satisfied, right? Similarly, so for homogeneity, if you are, for example, if for x1 t the output is y1 t, then you check for some alpha scalar multiply time x1 t, what will be the output. Okay, so for this input you just again substitute this quantity in this expression and see that the output is yt equal to will be e to the power t alpha time x1 t and you can just write it alpha time e to power t x1 t, right? And e to power t x1 t you have assumed it to be y1 t, right? This output, so it is just alpha time y1 t. So again you see that the homogeneity property is also satisfied. So the system will be linear, right? Because both properties are satisfied, superposition and homogeneity. Okay, and for causality you just have to check how this output is dependent on the input. Okay, so as you can see, it's just the output at the time t dependent only on the input that is given at the time t. Okay, so it does not depend on the future inputs, so that system is also causal. Okay, so the system is both linear and causal. Okay. Okay, so we can then move to next question also. Okay, so again a similar type of question. So we have two type of system. So system 1, which is yt, the output, which is given as xt plus some c. C is some kind of constant you can assume, so this is called bias term. And the second system, which is output is zt, which is just equal to xt. So then you have to see what condition given below is actually true. Okay, so for this question 5. Okay, okay, so you can see the poll and you can answer through this poll. Okay, again you can just check because the option has only linear and non-linear, so you can just check whether these two property, that is superposition and homogeneity, are satisfied for the given systems, and then you can just conclude whether the system is linear or non-linear. Okay, okay, so I hope you can see the poll, so you can answer through the poll. Okay, if you have any doubt regarding the question, you can also ask. Okay, if something is not clear regarding that question, or whatever I am explaining, if something is not clear, you can like interrupt and ask. Okay, so okay, then I will end this poll and then I will discuss this question. Okay. Okay, so again you have to check like these two properties, right? And this superposition and homogeneity. So just consider first the system 1. Okay, so you have yt equal to the input plus some bias term is given. Okay, again, so you assume for first checking the superposition, you assume that you have two inputs, x1 and x2, and let the output, corresponding output will be y1 and y2 for system 1. Okay, so then from this expression you see that y1 will be simply x1 t plus c, similarly y2 will be x2 t plus c. Okay, so then you give this input is a summation of these two, that is the x1 plus x2, and see what will the output for this corresponding input. Okay, so then again using this equation you just see that this output yt will be simply, in place of xt I am putting this summation of these two, so I am x1t plus x2t plus this constant c. Okay, so you see that this is x1 plus t plus c, I can write like this, plus x2 t plus c minus c I can write. I just added a c and subtracted c. Then it is y1 t plus y2 t from these two expression. Okay, minus c. So as you can see, this yt is not equal to y1 t plus y2 t if c is not equal to 0. Okay. So you see that this superposition property does not hold. Okay, so if any one property does not hold, then the system will not be linear. But anyway, we will check the second condition also. This is the homogeneity condition, and we can see that the output y2 will be, if we are giving some input like x1t alpha times of this, then you see that it will be, output will be alpha x1t plus c. Okay, so then it will be not equal to alpha times x1t plus c, which is actually alpha times y1t. Okay, let me write it clearly. Okay, which is not equal to alpha times y1t, because y1t is x1t plus c, right? As you can see, the c should be multiplied with alpha there, only when, then only it will be equal, right? So again you see that this homogeneity property is also not satisfied. So clearly you can see that system 1 is not linear. Okay, it's affine system, so it's called affine because of presence of this constant term. Okay, for the second system it is easy to verify that both linearity and homogeneity property will be satisfied. Okay, because this absence of the c, you can see that from this expression, if c is equal to 0, then yt will be equal to yn plus y2, and similarly also the scaled version, that is the homogeneity property, will be satisfied. Okay, just you can check, this is just simple. So you can see that just presence of this constant term also, then it is not linear by definition. Okay, so it's called affine. So you can see that system 1 is actually non-linear, depending on this our definition, that is it does not satisfy this homogeneity and superposition property, but system 2 satisfy both linearity, superposition and homogeneity property, so system 2 is linear. Okay, is it clear? Okay, so then we can move to next question then. Okay, so just basic simple RLC circuit, and you have to obtain the expression for all the other variables. You just eliminate I1, this current I1, then obtain the relation between this inductor capacitor voltage and the input voltage and the I2 current. Okay, so again this is very simple question, so we can just answer this. So this first question will be very simple, because only this modeling part is covered in this lecture video. So the question will be very basic type question. Okay, so you can see the poll and you can answer through this poll. Okay, so then I'll end this poll and discuss this question. Okay. Okay, so so you just apply the KVL and then write this voltage equation, right, for each of these loops. Okay, so for the first loop, this one, so you have this voltage Vt equal to I1 R1 plus I1 R2 minus this current is in this direction I2, so we have I2 R2 plus Vc. Okay, so I'm assuming this, so when I move from positive to negative, I'm assuming positive, and for this opposite I'm assuming negative. Okay, convention. So this is the first equation for the first loop. For the second loop, you can write this equation again. So this is I2 R2 minus I1 R1 plus Vc equal to VL. Okay, or minus VL equal to 0. Okay, write like this. Okay. So then you have to eliminate I1. So I can choose I1 from this. Okay, just simplify this. Okay, first. So it is I1 R1 plus R2 minus I2 R2 plus Vc. Okay. So one way to eliminate I1 will be like you find a relation between I1 and other variable from the second equation, or you can also, if you know like basic circuit theory, then you know that this voltage is same to this voltage, right, at this point. This voltage is just VL, right, so this voltage will be also VL. Okay, so then this current will be this V1 minus this VL by this resistor only, right. So this I1 will be V minus VL by R1. Okay, also from this second equation you can find this same expression, that is okay, so I am writing this I1 R1 is there, so I am taking all this quantity into like one side. So I have I1 R1 minus I2 R2, I am taking to other side. Okay, okay, sorry, this one VL and this is VC, sorry, because of the sign convention. Okay, so this is Vc minus VL, okay, equal to 0. So I can add I1 R2 on both sides, so it will be I1 R1 plus R2 minus I2 R2 plus Vc minus VL equal to I1 R2 R1, sorry, right, this R2, okay, because this resistor is R2. Okay, so then this expression is simply, you can see from this equation is Vt, so you have Vt, this first expression up to Vc, then we have minus VL equal to I1 R1, so you have I1 equal to again VL minus, sorry, Vt minus VL by R1. Okay, is clear? So in both cases you get the same expression for I1. Okay, so you can use any of these approach. Then we just put for this I1 value here and just simplify this expression, that's all. So we have this I1 equal to Vt minus VL by R1, so you substitute for this I1 here in this Vt expression, so you have Vt okay, so Vt equal to, so we have I1 and we have this is Vt minus VL by R1 into R1 plus R2 minus I2 R2 plus Vc. Okay, okay, so you just substitute for I1 from this expression, so this is the expression. Then you simplify this expression. So you need in terms of VL, right? So you keep this VL, so one side, so it will be VL times R1 plus R2 by R1, and you take all other to one side, so this will be Vt times this Vt and this Vt expression and this Vt expression, right? You just simplify this, nothing else. So you can see it is R1 this minus 1, so you have R2 by R1 minus I2 R2 plus, sorry, this is V, yeah, plus Vc, right? Then you just divide this quantity, so we have, okay, I have little space there, so I'll write, okay, I'll just remove this and write, sorry, space is very little here. So you have, then you have VL equal to, then just you just multiply this reverse reciprocal of this on both sides, so you have Vt times R2 by R1 plus R2 minus I2 R1 R2 by R1 plus R2 plus Vc means R1 by R1 plus R2. Okay, this is the expression for VL. So this is Vt R2 R1 by R2. Okay, so this D option. Okay. Okay, so we can move to next question then. Okay. Okay, so if anything not clear, please ask. Okay, so I'm assuming that it's clear. Okay, so for this question we have again similar type of mechanical system. Okay, so mass spring system. So again very simple kind of system. So you just have to write this equation. Okay, force balance equation for this node where the displacement is x. Okay, so this is question 7. So okay, again you can answer through a poll. Okay, so you can see the poll and I can answer. So again this is very basic question. So okay, so we can then discuss this question. Okay, so again this is very basic question. So you have a mass spring system. So you have 2 points of displacement. One is here and another is at this point. Okay, at this connection point of these two springs. So for this point x, so you can write this equation. So again following this basic mechanics equation, you know how to write. At every point you have to have this summation of all forces should be 0. That's all. Okay, so this is the basic things you have to write. So the first x position, you can see one force is acting, that is the externally this force Ft is applied, and we have for this force we have like two kind of resistance that could happen there. One is due to this inertia of this mass, and another due to the spring K2, right? So at this point we have this inertia will be just double derivative of x, m times double derivative of x, okay, and for this spring it is K2 times this displacement. But here this displacement is what you can see, it is this x1 minus x minus x1, like at this point this displacement, the relative displacement. So you can write it this, it will be just equal to this applied force, or you just take this minus sign here, then this total summation of all forces will be 0. That's all, this equation. Okay, so that is just the B equation. Okay, and if you want to write this equation at this node x1, okay, again you have to just sum all these forces to 0. So one forces will be like due to the spring, and another force is due to the other spring, and there is no external force is applied there. Okay, so these two will be like equal to each other, right? So the summation will be 0. So that means you have K1, this displacement is here is x1, and here this is okay. So these two forces will be equal here. This force here will be like K2 into x minus x1, that is we have already computed, and here it will be K1 times x1. Okay, that means K1 x1 plus K2, I just reverse this sign, x1 minus x2 should be 0. Then at these 2 points this equation. Okay, so then move to next question. Okay, so you already have learned this analogy between electrical and mechanical system. So for this system you have to find this force voltage analogy. Okay, so this analogy means that you may have different type of system like electrical, mechanical, everything, but the mathematical description is same, right? So you have a, for example, here we have at this point x, you have a mathematical description, that is the second order differential equation. So you have to find what kind of second order differential equation you see in the electrical circuit with, instead of force you have a voltage. Then you can find this analogy between this mechanical system and electrical system. So okay, so the basic idea is that even though you have very different kind of systems like mechanical, electrical, their mathematical description will be very similar type. Okay, so that's why you just study only this mathematical model, so it can be applied to any system, that either mechanical, electrical, or any biological, or any type of system. Okay, so for this question, okay, again I'm starting one poll, so you just answer. Okay, so you find the analogy between this force and voltage. Okay, then what will be this equation, this mass balance equation there in terms of this voltage, like an electrical circuit. Okay, voltage and charge. Okay, I hope this question is clear, right? Okay, so one hint will be like how to write this will be like write one second order equation for electrical circuit. I hope you all have like electrical background, so you know like second order equation, like second order differential equation, where you can see this type of equation, second order equation in electrical circuit like RLC circuit, where you have a voltage as an input. Okay, So then you can just compare and see like what will be this equivalent between these terms. Yeah, there will be also a recording for this. Okay, yeah, this recording will be available. Okay. Okay, so then we can discuss this question. Okay. So if you don't also remember like this analogy between like what will be the analogy between this mechanical and electrical system. So just think about this is a second order system, right? Second order differential equation. As you can see, we have second order derivative is there, and just normal terms. There is no first order derivative. Okay, so just write one circuit like for electrical circuit. So let some voltage is applied, and some inductor is there, and a capacitor is there. So I'm not taking resistance. Okay, so why I'm not taking resistance also it will be clear. So let this voltage V, and this inductor this L, and this capacitor C. Then this equation will be something like this, right? I'm taking this minus plus. Okay, so we have L, this current let be I, then L di by dt plus 1 by C I dt equal to Vt. Okay, Vt. So in terms of charge, that is the, if we take It equal to some dq by dt, that is the rate of change of charge, then this same equation can be written as L d square q by dt plus q by C equal to V. Okay, so now we can see that this type of equation, that is we have a second derivative and a normal term equal to voltage. This is similar to this mass this spring system. So we don't have any damper. If there is damper is present, then you can take a resistance and then see we have a first order derivative also in terms of this charge equation, right? So then this analogy will be what? You can just compare these two equations and see this M. Okay, this M term here. Okay, I'm just writing again this here, so it will be clear both equation here. Okay. Okay, just remove this. Okay. Okay, so here M, this double derivative plus some term is there like k2 x minus x1 equal to, we have this force F. Okay, Ft, and this equation L q double derivative, this equation I am writing 1 by C q, okay, equal to V. Okay, so I can also subtract another constant charge something for this x1. Okay, and because this is k2, I am just denoting this C2. Okay, just to make this equivalent, nothing else. So now you can see this analogy, right? So your M should correspond to L, your K2 should correspond to 1 by C2, and your charge should correspond to this displacement. Then only you have this F and V analogy, right? So your equation is just then this equation. So this equation, okay, just you note that this C2 is in the denominator. Okay, so you have this L M equivalence and you have this spring, that is the K2 for this specific case, it is 1 by C2, okay, because the capacitance it appears in the denominator, right? And you have this charge displacement, and similarly Q1 that correspond to x1, and your Vt correspond to this your force, okay. Okay, so even if you don't remember this analogy, then you can directly also see this from like considering one circuit, okay. So you see that both equations that actually govern this mechanical and electrical are of similar nature, okay. Only these coefficients, they mean something in electrical system and they mean something in different, in mechanical system. That is, this inductor in the electrical circuit and its mass in the mechanical system, okay. For this representation you can have also like different type of representation, but in essence the mathematical model will be like similar type, okay. Only this coefficient will mean something depending on the what kind of system you are actually treating, okay. So then you have like transfer function, okay. If you know what is the transfer function, it's okay, because I think in the lecture video, that is actually in the week 2, there is a discussion on this Laplace transfer and transfer function, okay. So you have to find the transfer function between this x and f, okay. So the transfer function is just the Laplace transform of this output by input when all these initial conditions are taken 0, okay. So here this input is this force you are applying, and the output will be this displacement x, okay. We are just considering this displacement x only. The output could also be x1 also, okay. So we want to find the relation. This is a transfer function, okay. So for finding that, you just use the previous equation you have derived for the system, okay. So one equation you have derived is the node x, another you in the node x1, right, to match this force balance equation. Using that you can find this transfer function, okay. Okay, so yeah, you can see the poll and I can try and answer, okay. Okay, so for if you don't know like the Laplace transform, so just one hint will be like the Laplace transform of some function, okay, the derivative, let because we have double derivative here, so this will be some function x. If the Laplace transform of x is, I'm denoting capital X, so it is time dependent, so I'm then its double derivative will be okay. So yes, derivative, okay. Because you have the initial condition 0, so you can ignore these two terms, okay. For now only you just use this. If you have not gone through this second week lecture video Laplace transform, okay, these things you can use, okay. Where xs is the Laplace transform of okay, I'll just also mention these things. The Laplace transform of xt is capital X, and this Laplace transform of this ft f of s. So generally we denote this Laplace transform by capital letters, okay, and the time domain element by small letter. That's convention, nothing else, okay. Okay, so then we can discuss this question. Okay. Okay, so first we write this equation. We already have this equation to force balance equation that we have already obtained, so I'm just writing them here again. So one is okay, 2 here, so this is x minus x1, these two forces equal to this ft, right? One equation. And here we have another equation at this node point. This is k1 x1 plus k2 x minus x1, because I am taking other side, so this is equal to 0. Okay, so we take the Laplace transform of both equation. So okay, so I am taking Laplace transform of this equation, so it will be m xs, and this will be s square also term. Okay, square xs plus k2, this xs minus k2 x1. So I am also taking the Laplace transform of x1t Laplace transform. I am denoting it to be x1s. Okay, x1s is equal to f of s. Similarly, from the second equation I have k1 x1s. I can write this k1 plus k2 directly. So k1 plus k2 that are multiplied with x1, so this is k1 plus k2 into x1s minus k2 xs equal to 0. So from this second equation you can solve for x1, which is just k2 by k1 plus k2 xs. Okay, then you just use this to eliminate x1 from this first equation. Okay, this is the first equation, so that is so we have m s square xs plus k2 xs minus, so this k2 x1s, so in place of x1s you use this equation. So we have k2 into k2, so we have k2 square by k1 plus k2 xs equal to f of s. Then we just simplify this expression. So we have m s square, and if you this is k2 minus this term, right? So I'm just writing this k2 minus k2 square by k1 plus k2. Okay, which is equal to k1 k2 plus k2 square minus k2 square by k1 plus k2, which is equal to k1 k2 by k1 plus k2. Okay, so these two terms will simplify to that is k1 k2 by k1 plus k2, this term, and whole thing is multiplied with xs. I can take common from all, equal to f of s. So this transfer function will be, then we need this xs by f of s, then so that means this. Okay, so we have xs again, sorry, I'll write here. Okay, so we have then xs, this implies by f of s equal to, we have this term, so I will just multiply k1 plus k2 with this term, so that is actually coming in the denominator m into k1 plus k2 s square plus k1 k2, and in the numerator this term will, I'm just taking that term. Okay, so this is the transfer function. So we have k1 plus k2 in the numerator, and in the denominator we have m into k1 plus k2 s square plus k1 k2. So this C. Okay, Okay, so any doubt regarding this question or? Okay, so if you have any doubt, you can ask. Okay, so this was the final question for this today's session. So if you have any doubt, you can ask. Okay, so for this week we have very basic questions because just this introduction to this. Okay. Okay, so if you have any question, you can ask, or if you want to leave, also you can leave. Okay. Okay, any question like for you know? Okay, yeah, you can ask. Yeah, you
So
can.
can you please explain the pendulum?
Sorry.
Can you please explain the pendulum concept?
Okay, pendulum concept. Okay, sure. Yeah, not a problem. Okay, you have gone through this lecture video, right?
Yes.
Okay, so you have what kind of doubt you have? Like it's not clear like how that equation derived or
Yeah, equation.
okay, so just that is the mechanical system, so that's simple mechanics. Okay, so I think you don't need that like clearly understanding that just for feel of that how your system can be modeled. Okay, so for this pendulum system again you write this mass balance equation. So you have two kind of like forces there, right? So one is this uh, whatever this rotational force that is coming from this hinge, and another is due to this gravitational force, and you just balance this equation. Okay, so you write this this rotation, you have this rotational inertia, so for that you write this equation. So again that is basic physics. Okay, so I will just explain only like that. Okay, I cannot explain that physical concept. Okay, for this, so you have like two kind of forces there. Okay, so I'll just draw something there. Okay, for example there, so you have pendulum. Okay, so because this pendulum will be like rotating here, so you have some kind of rotational force there, like torque you called it, and there is a mass there. So this mass will be like gravitational pull. So this force and this force, okay, this torque, you just balance them. Okay, so for balancing that you need like because this rotational, this happening, this rotation there, and okay, so this mass it is falling like this in gravity. Okay, so and this is actually this pendulum, it's oscillating like that. That means due to this mass it will oscillate like this, right? Like this, oscillate this pendulum. Then because of it's moving there, so there will be another force in this hinge. Okay, that will oppose this rotation. So this is this torque, and this equate this component with this torque, and then write that equation for that pendulum. Okay, so this is just idea. Okay, so how these forces are coming? So this again, this how to calculate this inertia, and this force, this mg forces, you have to like find this component depending on this angle. So this is just physics that you know how these laws are applied. Okay, this this is what like how you write this equation for this mechanical system. Okay, so that thing you know from this physics only. Okay, so I cannot explain that thing. I can just explain how to model this equation. Okay, how this equation are coming like this KVL, KCL, how to apply this equation. Okay, again this equation comes from your basic fact that you assume that this equation hold. Okay, similarly for this mechanical system, like what kind of equation you have, like for this torque equation, force equation. Okay, so these are the laws you have to you know them, so you just apply them and write. And we'll go through this lecture video and see if you can understand, because these things is just only that you have to apply this force equation balance. Okay, here you have to balance this torque, and then you get this equation. And you don't need this equation like in this control engineering. That is just for to know how to model this equation, because there are a lot of things like in this prey-predator model. Okay, so you don't know how this model comes out, right? This differential equation. So there is some kind of, either you know some kind of rule that governs this. Like in the electric circuit, we know this KBL and KCL, and we write this equation. And also you can, like, if you don't have any kind of rule, you just come up with, like, experimental, and see how this input output is behaving, and you just find this equation. So like that, you have this kind of, rule in the mechanical system, like how these laws are, there are laws that govern this system of equation, and from that you write. So beside that, I cannot say much about this, because this is just mechanical system, and I'm not from that background. So I can just say that, okay, you can model like that. Okay, so just try to, like, see that lecture video and understand. And because that you don't need much of this, right? How these laws are coming, this is just in basic physics you have. So you just go through that, because otherwise you don't need this kind of modeling. Just how to model the system you are given, and see that, okay, it's always some mathematical description that actually capture this kind of all these dynamical systems. Okay, so, okay, any doubt, like, okay, from this how to find this system of equation for that, except that, okay, I cannot expand that thing. Okay, otherwise you have a doubt, like, any classification or any problem regarding that, so like basic control problems, you can ask. Okay, so if you don't have any doubt, you can also leave. You are free to leave. Okay, if you have doubt regarding any question or any concept only, so you can ask. Okay, so if no doubt, then we can just stop and meet in the next week. Okay. Okay, so